Hello students, this lesson is pretty much all about square roots and perfect squares. Our first definition is for a square number. I also call this a perfect square. So if you hear me talking about a perfect square, this is what I'm talking about. It's a number that is the result of another number being multiplied times itself, basically. So let's go ahead and do a definition with a text box. Oh, got that really big. Let's see. Bring that down a little bit. A number that can be expressed as the square of a factor. Okay. Let's talk about what that means. We're going to go down here. Okay, so if I have a square, we know that a square has all the sides are the same length. And we know how to find the area of a square. It's just like with a rectangle, you multiply side by side. So, or you can take one of the sides and do what we call squaring it. In other words, multiply it times itself. So if I have a square with sides 5, they're 5 all the way around. I only need 2 sides though to get the area. And so the area would be 25 because 5 times itself is 25. So the 25 is what we call a perfect square. So the 25 is the number that we're talking about here. So 25, the perfect square or the square number, and again I always call it a perfect square, is the 25 here. So let's go back up here to the top. A square root, we're going to define this. A square root is one of the 2 equal factors of a number. So if we're talking about the factors of 25, for example, the equal factors, the factor pair that has the same number times itself, would be the 5s for a 25. So if we go back down here and we show it on this square, and this is really kind of where these words come from, is the fact that a square has, you know, all the sides are the same, and if you multiply the side times itself, you get the area of the square. So that's really kind of where these words come from. So let's do this side in blue. So again, we have the 5 and the 5. Actually, you know what? Let's do a different number. Let's choose a different number here. Let's do, okay, so if this square had sides that were 7, then the perfect square would be the 49. But here we're talking about the square root. So we would say the square root of 49. And of course, the symbol looks like that. So the square root here would be the 7. Okay, so the perfect square would be the 49 and the square root would be the 7. Okay, let's go down here and we'll do kind of both sections at the same time. Okay, so show the perfect square on a square with variables. So if we had an x here and an x here, then the perfect square would be the x squared. Okay, so that's a perfect square. We need to remember that when we start factoring difference of squares. So over here, let's say I have a y there, and then, so my perfect square here would be the y squared, but my square root would be the y itself. So it's the number that you multiply times itself. On this one, this last little section here says show it on a square with a binomial. Alrighty, so if we had x plus 3, and x, we'll write it like this, plus 3 like that. So the square root in here, we don't want to write out the whole polynomial. We'll just write x plus 3 squared. So the perfect square in this situation is that x plus 3 times itself, like that. Over here, we use the same numbers here. The square root, so the square root is the part that's out here, the one side, x plus 3. let's go over here to this section. I need to make this smaller so we can kind of see the whole thing. I guess we don't have to see the whole thing. I do want to show this part right here, though. So perfect squares. What we need to do is we kind of, it's a good idea to memorize these. Perfect squares are numbers like the 1, the 4, and then 9 goes here, and 16 or whatever. For some reason they have like fractions right here. I'll probably write them over here. It'd be easier. The numbers that are the result or the product of a number times itself. Those are the perfect squares. So if we memorize them up to 10, that's a good idea, because when we start simplifying square roots, we're going to need to know what these numbers are. Okay, so the 3 squared is 9. I'm going to change colors since I was doing all my perfect squares in red. We'll do a perfect squares in red. 9, 16, 25, 36, 49, 64, 81, and 100. So those are the perfect squares up to 10 or up to 100. So let's do blue over here, and we're going to do, over here we're going to talk about square roots. So the square root of 9 is 3. It's actually plus or minus 3, but for these purposes we're just going to use the positive. Square root of 16 is 4. Square root of 25, 5, and so on. We'll just fill these in. So these are the things you really need to commit to memory. 11 is 121 and 12 is 144. Let's just make a note up there of those. So if you remember I'm up to 12, that's probably good. We can use our calculator for any others. Okay. You can, and when we talk about rational numbers, we're talking about fractions. So where it says rational numbers right here, we're talking about fractions. You can actually square fractions. What you do is you square both the numerator and the denominator. So, for example, they did a couple of examples for you here. 1/2 squared is 1/4, because 1 times itself is 1, and 2 times itself is 4. And then up here, where it says 2/3 squared, 2 times itself is 4, and 3 times 3 is 9. 3/4 squared, we would say 3 times 3 is 9, 4 times 4 is 16. 4/5 squared, 4 times 4, 16, 5 times 5, 25. So we could do the same thing over here, where if we took the square root of 9/16, that would be square root of 9 is 3, square root of 16 is 4. And then if we took the square root of 16/25, the square root of 16 is 4. Square root of 25 is 5. So it would be 4/5. So you can take the square root of fractions. You have to take the square root of both the numerator and the denominator. All right, what is an irrational number? An irrational number, now see, this was a rational number up here, okay? So rational numbers are numbers that you can express as a fraction. Irrational numbers, I have a kind of a different definition than my key has here. So I'm going to give you the definition that's on my key, but I'm also going to kind of give you my definition at the same time. So let's get our text box. And any number that can be written as a non-repeating, non-terminating decimal. Because I'm going to put that in there, but I'm just going to tell you that an irrational number cannot be written as a fraction, okay? So let's just kind of add that on here. I'll use my drawing tool and add that. You can use your text tool if you want to. Cannot be expressed as a fraction. And I'm not going to go into this in too much detail, but repeating decimals, any decimal that has like a pattern, okay, can be written as a fraction. And I'm gonna just write it way up here. Even a number like 0.435. So 435, 435. If it has a pattern and it repeats like that, it can be written as a fraction. What you would do is you would write the 435 over as many over 999, because you write the 9, you write it as many times as there are digits in the numerator. So you write the repeating part, the pattern, in the numerator, and then it would be over 999. And you can always write a repeating decimal as a fraction. But irrational numbers, what we call irrational numbers, those are numbers that we can't write as a fraction. The decimals just keep going forever and ever. Numbers like pi, okay, so, and you learned pi a long time ago, I'm sure. Pi cannot be written as a fraction with a pattern of any kind. Another irrational number would be square root of 2. That's called an irrational number. Square root of 3 is also an irrational number. These can't be written as fractions. So if we write them as decimals, they are approximations. They don't actually equal whatever that decimal is. Like, you know, sometimes we use 3.14 for pi, but it doesn't actually equal, it's approximately 3.14, because that decimal keeps going forever. And there's no pattern to it. There's no repeat to it. Okay. Give some examples of whole number square roots that simplify to irrational numbers. Well, that would be like square root of 2, square root of 3. So when we get these, if you get a square root of 2, we're usually going to leave it square root of 2. If we want an exact answer, then we need to leave it as a square root and not try to simplify it as a fraction. As a decimal. Excuse me. Give some examples of rational number square roots that simplify to irrational numbers. Now, when they say rational numbers, they're talking about fractions. Okay, so something like the square root of 2/5. That would be irrational. I can't simplify this. I can't, like we had up here, we had square root of 16/25. We can simplify that because those are both perfect squares. 2 and 5 are not perfect squares, so we can't simplify this. Square root of 1/2 would be another example. We can't simplify that. All right, so we would leave it like that. That's kind of the point. Okay, so if we have a quadratic equation, in other words, if we have an equation, if you have just like 2x equals 14, you can solve that. But if you have something like 2x squared minus, not equals, minus 14 equals 0, we can solve this, but there are going to be two solutions. So let's talk about how to solve this. Well, first of all, we're trying to get the x by itself, of course. So the step 1 is to get your 0-degree term on one side of the equation and your 2nd-degree term on the other side. When we talk about 0 degree, we're talking about a constant. In other words, the number. So we want to get the number on one side of the equation. So to do that, we just add 14 to both sides. 2x squared equals 14. Okay, so we have 2x squared equals 14. Let's just rewrite that down here. Okay, if your 2nd-degree term, in other words, the 2x squared, has a coefficient, get rid of it by using multiplication or division principle. So we're going to divide on each side by 2. That's what that's saying. So we end up with x squared equals 7. So now what we have to do to solve this is take the square root. I'm going to do this step up here. Step 3, I'm going to do it up here. Take the square root of both sides. And we, you should have learned this in like 8th grade, but just in case you don't remember it, so I'm going kind of slow through this. All right, so take the square root of both sides. Now that creates two different equations. It breaks it into two parts because when I take the square root of x squared, I do have x. But when I take the square root of 7, first of all, I can't take the square root of 7, and I'm not going to try to make it a decimal. I'm just going to leave it square root of 7. But it's going to be either the positive or the negative. Let's talk about why that is. If I said, what is the square root of 16, for example? Let me write this down here. I'll try to make this bigger so you can see it. Square root of 16. 16 is a perfect square. Well, 4 is the square root of 16. We always think about that. But what about negative 4? Well, negative 4 times negative 4 is also positive 16. So the square root of 16 is 4 or negative 4. So the way we write that is we write a plus or minus like that. Okay, so we would do the same thing with the square root of 7. And then my step 4 says, you know, approximate this into a decimal, which you can do. You can put in your calculator square root of 7. I just moved way too far. You can approximate it, but I would prefer that you leave it as a square root. But if you did, then you would say, on this side, you would say x equal, or not x equals, but x approximates to 2.646. And if you looked at that decimal on the calculator, you would see it doesn't repeat. There's no pattern to it. Or x approximates to negative 2.646. So let's say you have an equation like this where you've got this binomial and that whole thing is squared. You can still take the square root on both sides, which is actually the next part down. And when you take the square root of both sides, that's when it turns into two different equations, like I said before. So you've got that x minus 5 in parentheses equals the square root of 10. And then just like over here, it could also equal the negative square root of 10. Oops, equals. Okay, so then you can take that out of parentheses. And then in the next line, solve for the variable by adding 5 to both sides. So x equals 5 plus square root of 10. And this is going to be important when we get to quadratic formula also. And x equals 5 minus square root of 10. This is the way I would have you leave it. I would not have you do the decimal part. I would have you leave it like this. So we would say x equals 5, and then we could do a plus or minus square root of 10. The reason I'm leaving it like this is when we do quadratic formula, we want to leave it like this. Also, for math 3, you don't want to go any further than that. We don't want to see the decimals because those are not exact answers. All right, so let me go back to 100% here so we can see this whole page, or we can see part of it. We are actually going to skip we're going to do this part at the top, but then we're going to skip this part right here because it's just kind of redundant. In other words, it kind of repeats itself. And I can teach you how to simplify a square root without doing this part down here. So up here, let's look at these. Simplifying a square root is what we want to look at in the world. Let's see. Yeah, we can do it like that. Simplifying square roots. You know, square roots come in kind of all different shapes and sizes, so to speak. And if you have one like this, like x to the 10th power, what you have to do is think of that as like x squared times x squared times x squared times x squared times x squared. Because x squared times itself 5 times equals x to the 10th. Because you know you would add up all these 2, 4, 6, 8, 10. Well, I can take the square root of each of these because x squared is a perfect square. So what I'm really trying to do is figure out, can I rewrite x to the 10th as a product of perfect squares? Well, x to the 10th equals x squared times itself. You know what? Let's write it a different way. It equals x squared to the 5th power, because you know you would multiply those two exponents. So I can rewrite it like this, and then I can say, okay, the square root of x squared, x. So I took each one of these, and what we want to try to do is we want to try to get rid of that radical, which is the square root symbol, if we can. Sometimes we can, sometimes we can't. So this can be written as x to the 5th. That is what we would call simplifying a square root or simplifying a radical. Okay, let's look right here. So 121 is 11 squared. So if I rewrote this as the square root of 11 squared times the square root of x squared, both of these can come out from under that radical. the square root of 11 squared, or the square root of 121, is 11. And then, and again, I'm not worried about that plus or minus right now. The square root of x squared is x. So the square root of 121x squared is 11x. All right, let's look at the last one right here. I can rewrite this as the square root of 49 times the square root of, how do I want to rewrite this? Let's do, so that's x to the 6th, and then the square root of y to the 4th. To be honest with you, if you just divide this number by 2, that gives you the square root. So the square root of x to the 6th is x to the 3rd. You just divide that number by 2. The square root of y to the 4th is y squared. If it had a different number under there, then it would be a little bit more complicated. But if we think of x to the 6th as you can also write it like this, like that, and then y to the 4th. Okay, so then the square root of 49 is 7, and I think it's going to be easier actually when we get to some other numbers. The square root of x to the 6th is x cubed, and the square root of y to the 4th is y squared. So that is that square root simplified. Now, let me go back, make this as small as I can. What I want you to do is we're actually going to skip the rest of this page. So mark out the rest of this page because it's a lot of steps and it's just not necessary. Okay, so we're going to go on to the next page, and I'm going to try to get through this in like 8 minutes. All right, so this is really kind of the meat of this whole lesson. It's simplifying square roots. So writing square roots in simplest radical form. Now, when we say radical form, we mean do not use decimals. So simplest radical form means don't change it to a decimal. Leave it in radical form. Leave it under the radical. Okay, so let's try this number. Let's try the square root of 500. Okay, so what we're looking for is we are looking for the largest perfect square that will divide into 500. Well, I know 100 will divide into it, so let's try that. So instead of rewrite as many of the factors as you can as square terms, here's what I'm going to do. I'm going to rewrite this as the square root of 100 times the square root of 5, because 100 times 5 equals 500, and this can be rewritten like this. Okay, and then step 3 says let the square root cancel the square terms, blah blah blah. I'm not worried about all this. What we need to do is take anything out of the radical that we can. Okay, simplify anything that we can. So the square root of 100 is 10. The square root of 5 we can't rewrite as we can't simplify it in any way. So the answer is going to be 10 times square root of 5. That's how you simplify that. So I think that's actually a lot easier than these steps that you see here. So let's look at, let's see, square root of, and I'm going to use this example I've got here, x, y to the 4th, z to the 5th. Okay, this is square root of x times square root of y to the 4th times the square root of, and I'm going to change this to an even number, so z to the 4th times z. So what can I take out from under the radical? I can't take the x out from under the radical because I don't have an x squared, so I'm going to leave that square root of x. This z over here, this individual z, can't take that out from under the radical, so I also have a square root of z. Now, this one I can take out from under the radical. When I take the square root of y to the 4th, I just divide the 4 by 2. Okay, so that would be y squared. And then the square root of z to the 4th, same thing. Divide this by 2. So that would be z squared. Okay, so how do I rewrite this thing and make it kind of more concise than this? This is how you want to rewrite it. you're going to rewrite it. You're going to write the variables without the radicals first. Y squared, z squared. And then you'll do a radical with both of these underneath the radical, x, z. Okay. Let's look at one with numbers and variables. So how about square root of 300? Let's do x, y to the 4th, z to the 6th. Okay. So how can this be rewritten? Well, the square root of 300 can be written, I'm going to do this a little bit smaller, square root of 100 times square root of 3. And we just say root 3 here. Root x can't be rewritten. Y to the 4th, the square root of y to the 4th can be rewritten y squared. I already know that. I'm just going to divide the 4 by 2. Z to the 6th can be rewritten, square root of that, z to the 3rd. Okay, so now I need to take the 10 here, the square root of 100, and rewrite that as 10. And then everything, and then take the y squared, the z cubed. So I took care of these things right here, and everything else I leave under the radical. That's going to be 3x, and that's actually my answer. That one was a little bit more difficult. Most of the time what we're doing is we're just doing numbers, okay? So we can do fractions also. So let's try some with just numbers. Let's do 125 over 48. So the square root of 125 over 48. Well, let me think. All right, so what is the highest perfect square that divides into 25? So the numerator, what I'm going to do, and I'm going to leave this part out. I'm going to do this. For the numerator, I'm going to rewrite this as square root of 25 times the square root of 5. That still equals square root of 125. Okay, so I did that part. And then the denominator, I can rewrite this as square root of 4 times 16. I'm sorry. 16 goes into that. So I'm looking for those perfect squares that divide into this number. 16 divides into 48. So the highest perfect square that divides into 48 is 16. And that goes 3 times. Then what I do is anything that I can get rid of the radical, I do that. So I can get rid of the radical right here. I can rename that 5. This one I can't. So 5 root 5 over, this one's 4 root 3. Now, here's the problem. In a problem like this with a fraction, you cannot leave a radical in the denominator. Okay? So what I have to do is I have to simplify it. Let me show you how you do that real quick. What you do is whatever the radical is down here in the denominator, you multiply it times itself. But, you know, in fractions, when I multiply something by the denominator, I gotta also multiply that by the numerator. So then what I would do is, oh, I'm sorry, that's the wrong number. It should be a 3. Okay, so then down here on the bottom, square root of 3 times the square root of 3 is 3. So this ends up being 4 times 3 in the denominator. And this is 5 times root 5 times root 3, which is root 15. All right, so my simplified version is 5 root 15 over 12. Let's do another one. I think I might do another one with numbers. Let's try the square root of, let's do 100 over 40. Okay, so let's break these down. We'll do this. I'll do it right here. This is the square root of 100, which is 10. I'm going to just leave that like that for a second. Over root 4 times root 10. Okay, square root of 100, I can rewrite that as 10. Square root of 4, I can rewrite that as 2 times root 10, because root 10 I can't simplify anymore. But I can't leave the radical root 10. Can't leave this in the denominator. So I'm going to multiply the numerator and the denominator by root 10. And so 10 times root 10 is just 10 times root 10. That's all I can do with that. This right here, root 10 times root 10. I want you to think about this. The square root of something times the square root of the same thing equals that number, okay? So this is 2 times 10, which is 20. Well, I can still actually simplify this a little bit more. Whoops. Because 10 over 20 is 1/2. So then, because this 10/20ths is not simplified, divide by 10. So that's going to be 1 times root 10 over 2, or just root 10 over 2. Okay, that was a lot to kind of take in, I know. But we'll do some more of these on the classwork. I'm not going to worry about this right now because this is a lot to remember for now. The biggest thing I want you to remember is this part right here, though, like taking a 500 and simplifying that. What you're looking for, again, is the highest perfect square. So remember all your perfect squares, like 1, 4, 9, 16. So you're looking for the highest one. 25 would have divided into it, but that wouldn't have simplified it enough. So the highest one that I could think of was 100. So you rewrite it as the product of square root of 100 times square root 5. Anyway, we're going to do some more in the classwork. I'm going to stop this video because it's gone on long enough. Just if you're not quite understanding, especially this part down here, I'm going to do some more of these in the classwork.